Hello everyone. Today I will talk about our project Sunflower. It's a smart solar panel tracking system that used IoT technology to improve solar energy effectively. Many solar panels today do not move. They stay in one position, but the sun moves all day. So, if the panel does not follow the sun, it cannot capture sunlight well. That's why we created the system is follow the sun using smart sensor and motor. In presentation, I will show you why this problem is important, how our system works, and what kind of result we got. Our goals is to change how we use the solar energy. We are a team of students who wants to make solar energy more useful and effective. With our idea, we believe we can help people save money and produce more clean energy. In the project, we almost see a great opportunity for the real world use. Is not just a school project. This can be used in homes and farms, and it can make a difference. Let me now explain the main problem with today's solar panels. Solar panels work best when they face in the sun directly. This happened when the sunlight hits the panel at 19-degree angle. But most solar panels do not move. They are fixed in the one place. As the sun moves across the sky, the panel no longer faced it perfectly. This means the panel gets less sunlight and produce less electricity. So, if we want to get more energy from the sun, the panel need to follow the sun. That's it. That is the core problem. Let's talk about how serious this problem is. Study shows that static panels can lose 20% to 14% of energy depending on the where you live and what season it is. For example, in Jakarta, a study showed that two-axis tracking panel can make 21% more energy than static ones. Also, Bloomberg reported the clean energy investment reached 1.8 trillion in 2023. So the worst is investing a lot, but we are losing energy because panels are not effective. Even for a small house with a 5 kilowatt system, it's mean losing 1k to 2k kilowatt hours each year. That's a big, very, very big loss. This energy loss happening because of the how the earth moves. Every day, the sun rises in the east and sets in the west, and in different season, the sun is higher or lower in sky. But static solar panels do not move. They are set to face one direction. Sorry, I need to check the tech. Sorry. In the morning and evening, or in white winter, they are much less effective. To, to the fix, we need a system that follows the sun both during the day and during in years. Let's now define the problem clearly. The main issue is the static solar panels cannot change their angle. Because of this, they do not capture the sunlight as effectively impossible. The problem reduces the total amount of the energy we can collect from the us. In the it's not just small system are mm, that are affected. Large solar farms, which are used in many countries, also lose a lot of energy. So this is a big problem for the economy and also for the environment. If we want more clean energy, we need the better technology, of course. Why this is a serious problem for the future? According to the International Energy Agency, global energy demand will grow by 15% by 2015. That means we will need much more electricity. If solar system stay ineffectively, we will need to use more fossil fuels, which are bad for, of course, bad for the environment. Some studies say tracking the system can produce 13% more energy than regular fixed panels. In the northern US, another study shows showed us 49% increase with solar trackers. So, if you want to meet energy goals and help the planet, we must make solar panels smart. So, why are we still using ineffective system? One reason is of course cost. Manufacturers want to keep solar panel cheap, so they don't want to add smart or moving paths. Another reason is tradition. Many engineers focused on simple design. Also, many users don't even know they're losing energy or they're thinking tracking system are too expensive. So this problem continue not before it's hard to solve, but people are use it always. Who is the affect this problem? First, homeowners. When their solar panels are not affected, they get less energy and must pay more for electricity. Second, solar farms and business, they are lose money because their system take longer to produce enough power to cover their cost. 30, the environment. When we don't get enough clean energy, we still use fossil fuels. And finally, governments, they want to reach re- renewable energy goals, but this in fact slow them down. We can see the problem happening all around in the world. In California, India, Turkey, and many other countries, solar panels are common, but most of them are static. Study shows that the morning and evening hours energy production drop a lot. Also, during winter or summer, when the sun is lower or higher in sky, panel produce less energy. This shows us this problem is not just theoretical, it's the real, and we can see it every day. Now that we understand the problem, let me introduce our solution. We have to create a system that follows the sun talk out the day and all season. It is called a dual axis solar tracking system, which means it's move in the two direction, left to right and up to down. This way, the solar panel can always face the sun at the best angle. So, even in the early morning or late afternoon, it's still collecting good sunlight. We use smart component and motors to control the panel position automatically. Our system also uses the IoT technology. It means it's connect to internet. We collect data in the real time, like how much light the panel is receiving and angle of the panel and the amount of the energy it produce. All this data is shown to their user talk, a website or app using a platform like ThinkSpeak. If it's a very cloud day, for example, the system can stop tracking to save energy like this. With IoT, users don't need check the panel physically. They can monitoring everything remotely, even from their phone. I need to check this. Sorry. Um, Pro. We test our system in the real world. Compare it to a normal fixed panel. Our smart tracking produce um, 25% to 15% more energy. This is a big improvement, especially over long period of time. Our system can be used at home, on rooftops, or in large solar farms. It's scalable, which means we can build it small or large depending on the need. We believe this system is a big step forward in the making solar energy smarter and useful. Of course, no system is perfect, and so we want to be honest about the advance and the disadvance. The good part is it's increased the energy output, which means lower electricity bills and less harms to environment. Also, the IoT part helps the user tracking everything easily with data. On the other hand, the cost is a bit higher than basic static panel. It may cost $5 or $100 more per unit. Because it is a modern park, it also needs some maintenance from time to time. Another corner concurrence is cloud weather. Our system work well with sunlight, but in climate performance might need more testing. Still, we believe the benefits are stronger than drawback. Here you can see our flow chart showing how our system worked step by step. First, sensor detect the position on the sun by measuring light from different angle. Then microcontroller read the data and decides how the panel should move. Servo motors adjust the panel angle. Both horizon are vertically. The IoT system collect the data and send it to the cloud. Finally, the user can view the panel's status online in real time. Everything works automatically without the user need to anything m- manually. Let's take a look at our SWOT analysis. Understand our position better. Our main strength is our unique design. The dual axis system is more advanced than most existing produce. We also use IoT, which give us a competitive advance because users get real-time data and control. A possible weakness is higher starting cost compared to basic panel. Also, moving parts mean the system may wear down over time and need repair. But see a big opportunity in the future. The global solar market is expected to reach five $5 million by 2025. People want smarter, more effective solar system, and we are offering that. One threat is competition. Some components offer cheaper static panels, or the weather is another factor. We depend on sunlight, so cloud condition can affect result. Still, we believe our design give us a strong position in the growing market. Now let's talk about our component. We used a build system. First, the brain of the system is ESP microcontroller. It's smart, powerful, supported Wi-Fi. Then we have two SG19 servo motor that move the panel the two direction. To decide the sunlight, we use LRD sensor. This help the system understand where the light is stronger. For power, we have a small 5V solar panel to help the testing energy generation. We also use the breadboard and jumper drives to connect everything together. So for the software, we used Arduino IDE to write the code and ThinkSpeak or blank platform to the display to data. We use a simple tools are multimeter, a soldering kit, and 3D printer to create the structure. All of these are low cost and easy to find, which makes the system affordable and easy to rebuild. Let me explain how our system solves the problem. Our panels moves the two directions left and right and up down. This is called dual axis movement. Thanks to sensor, by the way, the panel always try to stay at the 19-degree angle to sun. That's the angle where it can get more energy. The IoT system send the data about how well the panel is work. If it's cloudy, system can adjust or stop movement to save power. This combination of mm, this combination of mechanical movements or smart decision making help us reduce energy loss by as much as 30%. Yeah. So our system takes what would we do, what we do being wasted sunlight and turn it into useful power like that. Let's talk about the system architect. This diagram shows the full structure of our system. A center where the ASP microcontroller, which revised light data from the 4 LDR sensor. Based on the sensor data, the ESP sends signal to servo motors. Their motors move the panel until the light is balanced, meaning is fraction in sun. At the same time, system send performance data to internet using Wi-Fi. User can check this data on the dashboard, talk platform like ThinkSpeak. So everything from sunlight detection to data mourning is handled one smooth circle. We followed a 20-week development plan. In the first week, we did research, designed the system, and found the necessary parts. 4 and 6 week, we built the hardware, write the first version of the code, and tested the basic movement. In week 7 to 9, we connect the system, the internet using IoT platform. We also improved performance and tested tested in under real condition. From week 10 to 20, we finished the final prototype, prepared or documentation, and with this presentation. In we revise funding, we plan to 3 more months to scale the production and prepare the system for marketing. When with 6 months, we hope start selling the system to real user. Let's talk about our marketing or competition. There, there are already some solar tracking available today, but most of them only move one direction. They are called single axis tracking, but we have dual. We proved more value with better sunlight coverage and smart controller at the competitive cost. As I maintained before, the global solar market is expected to reach $500 billion by 2025. So there's a big demand for smarter, more effective system like ours. We believe we are in a great position to enter this marketing and make a real defines difference. Sorry. Uh, our team. I am team leader. Hello, mom. Barkay on software side, lead developer. He worked on the code and data communication. Again, helped him and worked on writing and testing software. Alper hardware part, lead the physical assembly of the system, connecting wires, planting sensor, and attending motor. Everyone focused on building the prototype and running the physical tests. Together, we make a strong and balanced team where each member contribute in an important way. Thank you guys, by the way. We got it. Mm, Finally, we want to thanks the source to help us with valuable data and background knowledge. We use the Irena energy statistic like Bloomberg. The International Energy Agent help us to understand the future of the global energy needs. We also study paper from the IAA and journals like Renewable Energy and energy policy. This project was both education and inspiring for us, and we hope it will in, price other too. In condition, in conclusion, sorry, we believe that smart solar tracking is not just a technical upgrade; it's a step toward a better and more sustainability future. By combining engineering and smart technology like IoT, we can get more energy from the same sunlight. Sunflower is our contribution to the vision. That's it. Thank you. Thank you very much for listening, and we are happy to answer any question you may have.